Hello, we're having a quick look at transformations. Here I've drawn a triangle, and it's a right-angled triangle on a axis. Along this line, the horizontal line, is my x-axis, and the vertical axis going up and down here is my y-axis. And we're going to make some transformations of our right-angled triangle. The first one I've done here is I'm flipping my triangle from its original position here to the left. You can also call that a reflection. Notice the position of my original triangle. It's one above the line here, and it's one space to the right of my y-axis here. So when I reflect it, or when I flip it to the left, I also need my reflection to have that same gap. So it needs to be one space or one unit above the x-axis and one unit from the y-axis. So if I had my triangle that was set 2 or 3 spaces away, the reflections should also be 2 or 3 spaces away from my axes. Here I've reset my triangle into its original position. If I flip it vertically this time, instead of horizontally, where do you think it will end up? That's right, well, it'll be down here, won't it? So it's still one space away from the x-axis and one space away from the y-axis, but it's reflecting vertically, which is going down here this time. This time I've put my triangle on the axes, on the x-axis and on the y-axis, so you can see that there's no gap. I've got it right on the axis. That's because we're going to look at transformational rotation. Here I've set my rotational symmetry to be the center of my triangle. As it spins around the center of the triangle, it doesn't really move position. So the center stays the same, and the triangle is spinning around its center. So it's not moving around the axis here, it's spinning on one point. That's rotational symmetry around the center of a shape. You can count it going around. Can you see the starting position? Here we go. 1, 2, 3, and 4. So here we are. I've set up my rotational symmetry. So here we are. You can see the rotational transformation is happening right in front of us. So you can see that it's rotating around a point in the middle of the triangle. So the middle stays where it is. It stays in its continuously the same position, and everything spins around it. So it's got a center of rotation right in the middle. Okay, now I've reset my shape again. I've got it back on my axes, so the x-axis and the y-axis. This time, I'm going to pin my triangle right there on the corner. And I'm going to rotate it, instead of through the center, through that corner. I wonder if you can tell which way it's going to rotate now. Imagine I'm rotating it from this corner, so you've put a pin in there, so nothing else can move. Sorry, nothing can move on that corner, but everything else can move around it. Let's have a look at what that looks like. Here we are. So that corner is fixed, and we've got rotational transformation around that corner. See how it's moving? Let's put a few more details on our little grid here. Now you can see we've put turns here, so each one of my axes has a turn. So this is our starting point, and we get to here, it's 1 turn. When we get to the second one, it's 2 turns, third line is 3 turns, and back to the start is 4 turns. That's what it means when it asks you in questions, how many turns will it take to get our shape into a certain position. It's asking you how many times can you put it through a 90-degree turn. Let's put degrees on our little grid here. So now you can see the circle that this is creating. See the point moving around here? It's creating a circle as it travels around. And as that circle travels around, we can see the degrees of a circle. So one complete revolution or one complete rotation around our circle is 360 degrees. Because our axis cuts our circle 4 times, that means 360 divided by 4 gives us 90 degrees each one of these grid positions in between the axis. So let's have a look when we get to the starting point. So that's 0, followed around, that's 90 degrees. Add another 90 degrees, we get 180 degrees. Another 90 degrees, 270. And then to get back to the position, we started at 360 degrees. So we can see how many degrees each turn is. So 0 turn starts here. Our first turn is 90 degrees. Second turn, 180 degrees. Third turn, 270 degrees. And 4 turns to get back to where we started, 360 degrees. And that's rotational symmetry around a corner of our shape.